Next topic is biofertilizer. Biofertilizer and use of biofertilizer in horticulture crops. What is biofertilizer? It is a microbial inoculant. That means which are biological material used as a source of supply nutrients through various biological reactions in soils and plants. This is a preliminary definition of biofertilizer, very precise definition that biofertilizers are, it can be defined as preparations containing live or latent cells of efficient strains of nitrogen fixing, phosphate solubilizing, and cellulitic microorganisms which are used for application to seed, soil, or composting areas with an objective of increasing numbers of such microorganisms to accelerate certain microbial process to augment the extent of availability of nutrients in a form which can be easily assimilated by plants. What do you mean by in form which is easily assimilated by plants? Conversion of complex organic forms into simplest inorganic form or chemical form which is easily available and assimilated to the plants is called as a biofertilizer. It, according to the definition, biofertilizers are nitrogen fixing, phosphate solubilizing, and cellulitic microorganisms, mainly NPK, and others are calcium, magnesium, sulfur. Sulfur mainly because thiobacillus species which oxidize sulfur from residual soil to make availability of sulfur, which then produce sulfuric acid in small extent and reduce pH of alkaline soil also. That is the typical fungi, that is Thiobacillus thioxidans and Thiobacillus feroxidans. These are two species used in biological amendment, biological reclamation, saline and alkaline soil. Amendment itself is a chemical fertilizer, but biological fertilizer, so it has biofertilizers such as Thiobacillus thioxidans, Thiobacillus peroxidans. These are sulfur oxidizers which oxidize sulfur from soil to produce or to reduce pH of soil. That is sulfur oxidation. That is the main objective of sulfur oxidizing microorganism, which is also biofertilizer. So see the types of biofertilizers. That is rhizobium, azotobacter, azospirillum, blue-green algae, azolla, mycorrhiza, and I am talking about sulfur oxidizer and phosphate solubilizing microorganisms. These are types of biofertilizers. Now I will elaborate. Just a minute. Okay. Now I will elaborate the classification of biofertilizers according to Bhattacharya and Varma. Okay. These are Depending upon nutrients provided, Varma and Bhattacharya classified biofertilizer as number one, nitrogen fixing biofertilizer. That is nitrogen fixing biofertilizer for legumes. Their species of biofertilizer are rhizobium species, which differs according to types of crops, that is cereals, legumes, etc. etc. Then second, nitrogen fixing biofertilizer for cereals. In number third, number four, azolla and BGA, that is blue green algae. The next step, that is phosphorus mobilizing biofertilizer, or it is also called as phosphate solubilizing biofertilizer. That is number one, Bacillus. Number two, Pseudomonas. And number three, Aspergillus. Then second type, that is phosphate absorber, which solubilize residual phosphorus, that is fixed phosphorus, residual phosphorus, that is VA mycorrhiza, vesicular herbicicular mycorrhiza. The name of full form of VA mycorrhiza. In biological nitrogen fixing microorganism, the biological reduction of molecular nitrogen to ammonia is restricted to certain bacteria possessing the nitrogenous enzyme complex. These are two types. That is, number one is symbiotic nitrogen fixation. Number two, asymbiotic nitrogen fixation. It is generally accomplished by azolla with Amabina algae, that is BGA, and rhizobium is in association with legume. Just a minute, I will change the speakers. Okay. Can you hear me? Okay. Then symbiotic nitrogen fixation, which is accomplished by azolla in association with Anavena azolla, and rhizobium in association with legumes. Okay. The rhizobium species most widely used by fertilizers as a rhizobium. These are as follows. Number one type is nodal formulae, that is on legumes and on non-legumes. There are various species of family belongs to Rhizobiaceae, which is symbiotic in nature and which fixes almost 50 to 100 kilogram nitrogen per hectare. with legumes only. A particular rhizome species will inoculate specific legumes that are grouped into following. I will elaborate group rhizome species and associated with specific legumes. Okay, number one group is alfalfa group. The rhizome species is Rhizome meliloti, and legumes associated are some clovers and alfalfa species. Okay, number two group is clover group. The rhizome species particular is Rhizobia trifoli, and legume associated is clover. Okay, then soybean. Third group is soybean. Particular species is Rhizobium japonicum, and legume associated is soybean. Then number four, bean, peas and beans. Rhizobium facile and Rhizobium leguminosum. Associated species are Rhizobium vulgaris and peas. And coffee, the species associated are various species. That is, legume associated are coffee and groundnut. These are nodal forming species of Rhizobium. That is nitrogen fixing symbiote. In non-nodal forming, azolla. It is floating water form. It is a symbiotic association between Anabina azuli. Anabina azuli utilizes energy from photosynthesis to fix atmospheric nitrogen up to extent of 100 to 150 kilogram nitrogen per hectare per year. And number two, non-symbiotic nitrogen fixing microorganisms. There are for non-symbiotic nitrogen fixing there are two processes, that is known as aerobic process and anaerobic process. Okay. For aerobic, the specific genre associated is Clostridium and Chlorobium. Then these are azotobacter. We have to inoculate seeds with azotobacter culture for increasing yield of crop, which fixes as 3 to 15 kilogram nitrogen per hectare per year. Okay. The specific species are Azotobacter curcum in neutral to alkaline soils. Azotobacter agilis is aquatic species, and Azotobacter beijeringia, which is typically found in tropical soils. Next, blue-green algae, which fixes at the rate of 10 kilogram hectare per year in a rice fields. Then mycorrhiza, a symbiotic association of fungi with roots of vesicular plants. It is termed as Ram fungi. That is known as a vesicular arbuscular mycorrhiza, which has been observed in fruit crops like citrus, papaya, and lychee. Then last one is azospirillum. Certain microorganisms colonize the root zones and fix nitrogen in loose association with the plants. Azospirillum is one of them, which applications are majorly maize, oat, barley, sorghum, grain crops. Then last type of microorganism, that is sulfur oxidizing microorganism. Like I told you before, Thibacillus thioxidans, and Thibacillus peroxidans. These are two species which oxidizes sulfur from soil and mineralization of sulfur. It is converted into mineralization of sulfur, which produce sulfuric acid to some extent and reduce pH of alkaline soils. Then next, phosphate solubilizing organism. The main form of phosphorus or nature of phosphorus is to get fixed in the surface soil. Whenever we apply phosphorus, phosphorus has a tendency to get fixed in the soil. That means it is not available to the plants. That phosphorus is solubilized with phosphate solubilizing organism, which solubilize this fixed phosphorus and make available to the plant in a form which is easily assimilated by the plant. For example, bacteria, Bacillus megabacterium, and Bacillus fungi. The next species is fungi. Aspergillus niger, Aspergillus habeas, and Penicillium digitatum and Oxysporium. There are species. Then we generally categorize bacteria as genus and important species. The important genus are Bacillus and Pseudomonas. In Bacillus, the important species are Bacillus subtilis, Bacillus polymexa. And in Pseudomonas genus, the main species are Pseudomonas strata. And in fungi, the important genus are Aspergillus, and the important species is Aspergillus avamori and Aspergillus fumigatus. Then next important genus for fungi is Penicillium, and species is Penicillium digitatum. So it is all about biofertilizer.